Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. In this summer series of podcasts, we introduce you to the winners of our Teledyne Marine Academic Grant for 2020. This grant offers universities and institutions the opportunity to utilize several of our flagship products free of charge for up to a 6-month period to support their research programs. In this episode, we meet Boguslaw Cyganek, a professor in the Department of Electronics at AGH University of Science and Technology in Poland. His research focus includes computer vision, pattern recognition, and artificial intelligence, as well as development of programmable devices, acceleration of computations and embedded systems, with special focus on autonomous automotive and underwater systems. He is an author or co-author of more than 100 journal and conference papers, as well as books. His latest, Object Detection and Recognition in Digital Images, Theory and Practice, was published by Wiley in 2013. Together with his students, Professor Cyganek will be using the awarded BlueView M900 MKII sonar to further his algorithm development for underwater object detection. Now, here's Boguslaw Cyganek with the host of Marine Tech Talk, Melissa Rossi.
Professor, you teach in the Department of Electronics at AGH University of Science and Technology in Krakow, Poland. Can you tell us a little bit about the program that you teach there?
Okay. Yes, I'm a professor at the Department of Electronics and teaching to the students of electronics, teaching computer science, basics of computer science. So this is mostly about operating systems, computer languages like C++, but most of all, I am teaching computer vision, machine learning, artificial intelligence, and also doing research in this area. Also with a very young team of PhD students and master students, very enthusiastic. So my background is in electronics, but I pursue computer science, and also I have some background in underwater exploration because I am a scuba diving instructor in Poland.
Oh, okay. So your university just recently won one of our Teledyne Marine Academic Grants. So congratulations on that win. That's pretty exciting.
Thank you very much. This is a great thing for us. Thank you once again.
Were you surprised to learn that you had won the award?
Yes, I was very surprised because we just wrote this application and we are counting to have this grant, but we are aware at the same time that many groups around the world, they applied as well. So I was even more surprised by having a phone call once and hearing that we won this opportunity.
Yeah, we were pretty excited about it too. We did have a large pool of applicants this year, which was great, literally from all around the world. I recently interviewed somebody in the UK, and tomorrow I'm interviewing somebody from Mexico. So you're in a good group of researchers that represent a big, broad swath of research across the globe. Your abstract was really interesting, and I'm wondering if you can tell our listeners about what you're doing or what you're intending to do in your research and how you're going to use the BlueView M900 MKII sonar that you were awarded.
Yes, that's right. As I mentioned, I'm doing research in computer vision, and recently I managed to join my hobby of underwater explorations and underwater computer vision, which is a challenge by itself because of conditions, certainly. So our recent scientific project is aimed at constructing mostly algorithms, but also devices to acquire some underwater signals, video signals, but also sonar signals, and then construct algorithms mostly based on artificial intelligence and on convolutional deep neural networks to find, to detect some objects which we are looking for underwater. But the most interesting thing in this exploration is that in many cases we are not able to precisely define what actually we are looking for. But we follow some natural observations. So, for example, if we are doing scuba diving for us humans, it is quite easy to spot some human-made objects underwater. So we try to construct similar algorithms which can also look for some sunk objects or objects which are to be found underwater.
Yeah, that's really interesting. It's interesting how you could more or less teach through an algorithm or I guess the deep learning for an automated system to be able to detect something, maybe not quite in the same way that a human would. It was also interesting as I was doing a little bit of background research, the term, I saw the term convolutional neural networks, which was really interesting because obviously neurons are something that transmit nerve impulses in living organisms. And somehow that terminology is being translated to this deep learning or AI. How does that actually translate? Is that the algorithm that you're using? Is that what it's equating to?
Yes, actually this is a great revolution, AI. Although neural networks are known for something like artificial neural networks, are known for something like 50 years already. Only recently, last 8 years, they just made a big revolution, technological revolution. It was a synergy of many factors, of some theoretical achievements in neural architectures, but also in advances in fast computational platforms based on graphical processing units. And these two branches allowed us to construct quite useful and powerful classification systems. All these systems are based on some biological resemblance to the neural networks, as you mentioned. But I would like to stress that these are mathematical models. There is no biology inside except
sure.
except our algorithms. So this is the main tool we are using now for all classifications. But they are not automatic. They need to be trained, and for this purpose, they need to be fed with a lot of data. So in this context, this sonar can help in acquiring new signals, new images, and finally to train new neural architectures.
So have you been working in the underwater environment already on previous projects building these networks and detection capabilities?
Yes, we are doing this research for years, but previously we are just focusing upon stereo systems based solely on video signals. But as you know, as we all know, some parts of water are not best to be processed with video signals. There are some turbid waters, and only sonar is used in such places.
Yeah, I think that's particularly interesting to people who are running systems that would benefit from the object detection. So certainly really dark waters, very turbid waters, as you said, cameras are no good. So somehow they need sonar, and they need an ability to be able to object recognize.
Exactly.
Is this the first time you've used a sonar in your studies, or will this be the first time that you've used a sonar in your studies?
This is quite interesting history because we're just watching possibility of using, I would say, sonar cameras, so 2D imagers, but they were out of our reach because of costs, especially in this project. So although we planned the usage at the beginning, we ended up with side sonar, triple S. So, but it has different properties. It needs to be towed under the boat, and also it is producing acoustic signal, but only acquired for a line at the time. So all these lines have to be set up to form an image, and this is quite time-consuming and sometimes difficult process.
How did you actually learn about the Teledyne Marine Academic Grant?
Well, I subscribe to Teledyne newsletter, so I'm receiving.
Excellent.
It's
the best way to get the information directly from us. That's great.
Yes, but I'm observing what Teledyne is doing. So when I attend the conferences like SPIE, I always visit the booth of Teledyne, and I talk to the people from Teledyne to just know what they are doing, and they're always great in answering. So, but yes, it was newsletter, so thank you for sending.
No, that's great. It's great to know that people are actually reading through the newsletter and seeing what opportunities we have for them. And it's nice to be able to. I mean, obviously, you've been to visit us in booths, as you said in the past, and you've been keeping up with the information from us. It's nice to see us be able to give something back to you. So that's great. I know you're not exactly clear because you haven't received the sonar yet, but where is your intended project location and what are your intended timelines for the project?
We're already discussing this issue with my team, so as soon as we receive this device, we can try it here. In my city in Krakow, we have beautiful artificial quarry, artificial lake, Zakrzówek. So we are doing a lot of simple research there. Certainly, we also start with new devices. We start in the swimming pool just to get knowledge how it operates. We are all constrained by this COVID-19 situation. So it is just breaking a lot of plans. But hopefully, in a month or two, we'll be able to go to the sea. We have Baltic Sea up north of Poland. We have beautiful and deep lakes in northern part of Poland. So maybe on one trip of couple of days, we can do the two places. And we have also collaborators in Croatia, in Adriatic Sea, some scuba diving centers and archaeological places. So we can help archaeologists also and do some research in Croatia. Usually we go to the Hvar Island. So we have couple of cooperators from scuba centers there. So we count on them.
Do you have an expectation on the results that you'll get back from this study? Are you expecting certain outcomes?
Yes. As I mentioned, these modern neural networks and the classification systems, they all need a lot of data. So although visual data are quite easily accessible, for example, from YouTube and other databases, underwater images are not so popular, and even less sonar images. So the first thing is just to collect a large database of sonar recordings, then process them, and then to train neural networks, which we already have some algorithms working, but waiting for more data. So probably we'll set up experiments. The first one is to search for specific objects. We have a cooperation with some marine universities in the projects of looking for underwater mines, sometimes from the Second World War. And the second experiment will be, as I mentioned, to look for some objects which we don't know exactly but they are, for example, regular, or they have specific color, or they are parts of something what neural network was already trained in. So we'll see how it can operate with sonar images. As far as this is quite new research, there are no sonar databases quite available, so it will be something new.
Yes, and you should be able to get hopefully lots of data to fill that pipeline full of data needs, because I think the grant is a 6-month running grant, so hopefully you'll be able to deploy numerous times over the six months period and be able to get a sufficient amount of data that will help your research.
Yeah, I hope so.
What role will your students play in your research? What do they actually do on these research missions?
Well, actually, my whole team are my students, mostly these students, Mateusz, Jakub, Jan, but also we try to attract younger students from engineering studies and master studies to follow our research. So usually they help in writing some algorithms, but many of them are helping in preparation of the equipment. But also I would like to mention that I have other group of students of scuba diving classes. So yeah, they are quite eager to help in scuba diving. So they are so nervous to go to the water and do something interesting. So if I propose some real stuff, I mean measuring something or doing something for more than only scuba diving, they are so excited that they help in this research as well. So there are also some scuba divers who are engineers, but they also are thinking of doing PhD thesis, joining the two domains. So there are many groups of young people cooperating.
Well, it sounds like a great way to get new people into the program and get them exposed to the technology and to the science that you're teaching. That's great. What challenges, if any, are you anticipating to run into?
Good question. Well, actually, there are many challenges all the time. So what I mentioned, this COVID situation is quite changing everything. So hopefully, the borders will be open again, and we can go somewhere and do some research. But in the domain of research, actually, we'll usually have many questions and no answers, and quite often equipment or software, especially software we develop, is not working at the beginning as we expect. So this is what I'm saying to my students. If something starts working very well too fast, then probably you made a big error. Yeah.
That's a good idea.
Yeah. So usually this is some work to prepare experiments, then some fun acquiring images, doing these experiments in the water, and then there are many hundreds, thousands of hours of work with the computer, with the algorithms, with training neural networks, writing software, and looking why it is not working the way I was expecting.
Well, hopefully that won't happen. Hopefully it will work exactly the way you expect it to work.
Well, hopefully we will come to the result which is acceptable. This is well, usually we have some good results, but as I mentioned, it is not that simple. It is not short time.
Do you have a plan for how you're going to deploy the BlueView sonar?
Yes, actually we have some experience with this site sonar. So we also do some underwater works. I was underwater welder for years. So we know how to construct electronics and some underwater devices. Also, we already read some manuals about this particular device, so we know what to expect. And, well, I think yes.
Great.
The answer is yes.
Let me ask you a question. So this is an evolving technology, I guess maybe is the best way to put it. So you're, obviously still in the phase of gathering enough data to create the algorithms that will be able to successfully identify unknown objects underwater, because that's the goal, right? So we don't know what it is, and the software is able to locate it, identify it, and potentially alert somebody, especially if we're talking about, as you mentioned earlier, in the areas of like mine countermeasures or things like that. Obviously, it's important to know before we get to the mine that something's ahead. That's not good. How far away do you think this technology is from being an available technology that's a functioning technology for researchers, for the military? How far away do you think we are from an actual product?
Well, I think the simple answer is depends on expectations. But I know that this is already a product, but there is an issue of human supervision. So with modern approaches, we have less on humans and more on technology. So this is the way. So far, if you are doing some underwater constructions, you can use sonars for years, but you have to input data by yourself. And now you can have machines, some underwater drones, which can be fully autonomous because they can interpret the scene and take decisions underwater without the human operation. So this is where we are aiming, so where we are going. But what we wish to achieve is, depends on the needs.
Right. Well, that sounds great. I'd be very interested to hear what your outcome is, even from using the equipment this year. And actually, I'm hoping that we can get you back on the podcast maybe towards the end of the year after you've had a chance to use the BlueView sonar and just hear how the experiment went, how the data looked, and how your project is going.
Sure, you can count on me. Thank you.
All right, that sounds great. Well, thank you very much for joining us. Our readers or our listeners will be able to see in the show notes some links to some information about what Professor Cyganek and his team are doing with the BlueView sonar, and we'll keep you up to date. All right, thank you very much, and good luck with your research.
Thank you.
Thanks for listening to the Marine Tech Talk podcast. If you have any comments or questions about the show, you can email host Melissa Rossi at marinetechtalk@teledyne.com. If you like this podcast, please make sure to subscribe on Apple Podcasts or wherever you're hearing this show. That way, you'll never miss an episode. Thanks for listening, and we'll see you again next time.